Elements, compounds, and mixtures. Section 3. Mixtures. Key concept. A mixture is a combination of two or more substances that are not chemically combined.
As you read this section, keep in mind what you will learn. Mixtures can be separated by physical means, such as distillation, filtration, and evaporation. A solution is a mixture that appears to be a single substance, but is composed of a solute dissolved in a solvent. Concentration is a measure of the amount of a solute dissolved in a given amount of solvent. Why it matters. Most everyday materials are mixtures, so it is helpful to know the characteristics of mixtures. In this section, you will learn the following new vocabulary: mixture, solution, solute, solvent, concentration, solubility.
Imagine that you roll out some dough, add tomato sauce, and sprinkle some cheese on top. Then you add mushrooms, olives, and pepperoni. What have you just made? A pizza, of course. But that's not all. You have also created a mixture. Properties of mixtures. All mixtures share certain properties. A mixture is a combination of two or more substances that are not chemically combined. When two or more materials are put together, they form a mixture, if they do not react to form a compound. No chemical changes in a mixture. No chemical change happens when a mixture is made. So, each substance in a mixture has the same chemical makeup it had before the mixture formed. That is, each substance in a mixture keeps its identity. In some mixtures, such as the pizza in Figure 1, you can see each of the components. In other mixtures, such as salt water, you cannot see all the components. Separating mixtures through physical methods. If you don't like mushrooms on your pizza, you can just pick them off. This change is a physical change of the mixture. The identities of the substances do not change. But not all mixtures are as easy to separate as a pizza. You cannot just pick salt out of salt water. One way to separate the salt from the water is to heat the mixture until the water evaporates. The salt is left behind. Other ways to separate mixtures are shown in Figure 2. The ratio of components in a mixture. A compound is made of elements that are mixed in a specific mass ratio. However, the components of a mixture do not need to be mixed in a definite ratio. For example, granite is a mixture made of 3 minerals: feldspar, mica, and quartz. Feldspar is pink. Mica is black. Quartz is colorless. Look at the egg-shaped paperweights in Figure 3. The granite of the pink one has more feldspar than it does mica or quartz, so this paperweight is pink. The granite of the black one has more mica than it does other minerals. The granite of the gray one has more quartz than it does other minerals. Even though the proportions of the minerals change, the combination of minerals is always a mixture called granite. Table 1 summarizes the differences between mixtures and compounds. Solutions. A solution is a homogeneous mixture that appears to be a single substance. A solution is composed of particles of two or more substances that are distributed evenly among each other. Solutions have the same appearance and properties throughout the mixture. The process in which particles of substances separate and spread evenly throughout a mixture is known as dissolving. In solutions, the solute is the substance that is dissolved. The solvent is the substance in which the solute is dissolved. A solute must be soluble or able to dissolve in the solvent. A substance that is insoluble or unable to dissolve forms a mixture that is not a solution. Salt water is a solution. Salt is soluble in or can dissolve in water. So, salt is the solute and water is the solvent. When two liquids or two gases form a solution, The substance that is present in the largest amount is the solvent. Examples of solutions. You may think that all solutions are liquids. Tap water, soft drinks, gasoline, and many cleaners are liquid solutions. But solutions may also be gases. Air is a solution that is a gas. Solutions may even be solids. Steel is a solid solution. Alloys are solid solutions in which metals or nonmetals are dissolved in metals. Brass is an alloy of the metal zinc dissolved in copper. Steel is an alloy of the nonmetal carbon and other elements dissolved in iron. Table 2 lists more examples of solutions. Particles in solutions. The particles in solutions are so small that they will not come out of solution. They also cannot be removed by filtering. Solute particles are so small that they do not scatter light. Both jars in Figure 4 contain mixtures. The mixture in the jar on the left is a solution of salt in water. The jar on the right holds a mixture, but not a solution, of gelatin in water. Concentration of solutions. A measure of the amount of solute dissolved in a given amount of solvent is concentration. Concentration can be expressed in grams of solute per milliliter of solvent or grams per milliliter. Solutions can be described as being concentrated or dilute. In Figure 5, the two solutions have the same amount of solvent but different amounts of solute. The solution on the left contains less solute than the solution on the right. The solution on the left is dilute. The solution on the right is more concentrated than the solution on the left. The terms dilute and concentrated do not tell you the concentration of solute. Solubility. If you add too much sugar to a glass of lemonade, some of the sugar cannot dissolve. Some of it sinks to the bottom. To find the maximum amount of sugar that can dissolve, you must know the solubility of sugar. Solubility refers to the ability of a solute to dissolve in a solvent at a certain temperature. Figure 6 shows how temperature affects the solubility of several solid substances.